Good evening, everyone. Welcome to the second session of Block Talk Season 1. Today, we will be exploring about the consensus mechanism, which is the backbone to blockchain trust and security. Before we dive in, let's meet our host. I am Dhrutinandan Swai, a full stack and a Web3 developer, and will be taking today's session. In today's session, we will be discussing about what is consensus mechanism, why do we actually need it, and we seeing the working of types of consensus mechanism, some of the popular types like proof of work and proof of stake. And also with that, we will be explaining and understanding the working of proof of history. So let's start with the discussion. So first question is what is consensus mechanism? You can let's first understand what is consensus. Consensus refers to the general agreement among the group, and in the blockchain world, consensus mechanism are the rules and the processes that ensure all participants in the blockchain or the decentralized network to agree on a single version of truth, like which transactions are valid or not. So there are various type of consensus mechanism, proof of work, proof of stake, and many more. And in technical term, you can see that a consensus mechanism is a cryptographic protocol enabling distributed nodes to agree on transaction validity without any central authority. So this is what a consensus mechanism really is. Next is why does it matter? Why do we need it? So let's understand the need of it through an example. We will be taking consideration to double spending example, which is a very common example that is used to know why consensus is required and why it matters. Without a bank, how do you stop someone from spending the same $10 twice? Consensus mechanism solves this by making everyone agree on the official record. So what it actually means is that in the digital world, it is very easy to copy the money. And even if you have $10, you can represent that you have $20 despite having $10 in reality. So how do you stop someone spending the same amount of money twice, like having 100 rupees and spending 200 rupees without getting into debt? So here is another example. Imagine you and your friends keeping a shared notebook of who owes whom money. But there is no teacher or no intervention that makes sure that no one cheats or write fake entries. So this is where consensus mechanisms comes into hand. Now let's see about types of consensus mechanisms. The first consensus mechanism is the proof of work. It's a pretty popular type of consensus mechanism that is used by Bitcoin and was used by Ethereum version 1. So let's understand that. So here is a representation of block. So if you want to know about block, you can go to the previous session that we had. It's currently uploaded in the YouTube as well. I'll be sending the link as well. So for as of now, a block you can refer it as a block is a page in a permanent ledger system where multiple transactions are bundled together. A block is a single entity of an entire blockchain. Multiple blocks chained together forms blockchain. So a block header means the typical data a block holds main data is the previous block has. As blockchain refers to the chain, so every chain has the access or has the reference to the previous chain so that it makes a immutable chain. So any data that has been tampered with, it's easily find out and rejected for the security purpose. Previous block has means the every block has an reference to the previous block it was connected to. Transaction detail, all the transaction that was bundled together in that block. Nonce. Nonce is stands for number used once. It's a special number that is computed mathematically and requires heavy computations to find out. Nonce is the thing that we are gonna focus more in the proof of work. Then comes the timestamp when the block was created and the difficulty target. It's basically a difficulty target or bar set by the blockchain network itself. So here is the block header. Once the block is initiated, The main task is to find the nonce, and nonce, as I said, is a number used once only. So, with the help of nonce and the transaction details, the hashed value, that is the hashed of the combination of nonce and the transaction details, is found out. And the hash is basically something that a fixed length of string. So if I more, the hashing is a process of converting input data into a fixed length string called hash using a mathematical function. For example, Bitcoin uses a hashing algorithm known as SAT256 to transform transaction data into a 256-bit string. So this is basically hash, a fixed length string. So after the initiation of the block in the entire transaction process, the miners, you can refer it to as the several computers running worldwide to find the value of the nonce, correct value of the nonce and hash. So there are, as you can see in the diagram, I have drawn multiple miners from -1 to -10. They are different individual miners competing against each other to find the correct value of nonce and ensuring that the hash generated from the block header, all these details, meets the network's predefined difficulty level. That's the difficulty target itself. So as let's see, understand from this diagram, here is a group of miners from -1 to 10. Miners compete to determine the correct nonce value, ensuring that the hash generated from their block header data meets the network's predefined difficulty level. So, in simple terms, miners compete in a race to find out the correct value of nonce and the hash among each other. The one who solves the correct value of hash and in the first and in the shortest amount of time wins the race. So, after let's suppose miner one discovers the hash value. This hash is then broadcasted among the network or the nodes or the different miners for verification purpose. If the has or the nonce is has been confirmed as correct, then the block is added to the blockchain. As you can see, block one, here is our block, then here comes the next block. So after the miner discovers the correct hash and wins the race, their result is broadcasted into verification. And after verification and everything, the block is added to the blockchain. The miner receives the block reward as well as a transaction fees. The transaction fee you pay for your transaction processing is goes to the miner who finds the correct nonce value. So this is about the proof of work, I guess. So does anyone have any value on this proof of work? It is a simplified explanation of proof of work itself, the concept. So I guess no one has any doubt. Let's move towards the next type of consensus mechanism, proof of stake. So proof of stake has been currently used by Solana and Ethereum 2.0. So let's understand that. It's very similar to proof of work, but the mechanism is very different. I will explain it very simple way, so stay with me. So here comes the block header, the block itself. So here comes the pool of validators. Now in the previous proof of work, there was a concept of miners. Now, in this, there is a concept of validators. So, as you can see in the pool, there are from validator 1 to 9. So, let's explain how it works. Once a block has been initiated, so as there are no miners, how is the nonce calculated? How are the blocks verified? How are the transactions bundled into the blocks? Like who is the responsible one? So everything that is said comes the responsibility to the validators. As you can see, validators in this proof of stake their own coin or their own money to become one of the lead validators who are able to make the block, select the transactions, and add the block to the blockchain. For example, as you can see, validated one staked 100 rupees, $100,000 of his own money or coin. Validated two, $400. Validated three, 500. So that like all the validators have staked their own money. Then there comes an algorithm in the network that chooses the validator, the lead validator from the pool of this validator. And the choosing here like highly depends upon the amount you are staking. Higher the amount you stake, higher the chance of getting selected as the lead validator. As you can see, validators take their own coin to increase their chances of being chosen as the next validator, responsible for adding a new block to the blockchain. The higher a validator stake, the greater the probability of selection. So, as I said, a lead validator is responsible for adding a new block to the blockchain, and higher the validator stake, higher the individual validator stakes his or her own money, the greater the probability of selection as the validator lead. So let's suppose validator one is chosen to add the next block. As you can see, validator one stake the highest $1,000 or 1,000 coins is chosen to add the next block because they stuck the highest amount. After the block is created, other validators verify its accuracy. If the block is valid, it is added to the blockchain. However, if it contains false transaction, the validator faces slashing as a penalty. So let me uh, brief it down. So after a block is created, other validators verify its accuracy. It's not like that only one validator lead will be selected. There may be multiple validators that can be selected, and each will be given turn to add a block to the blockchain. So after a particular validator has created a block, all the rest of the remaining validators verify either the block and the transaction in it are true or verified and are like according to the rules and regulations or not. If the transaction is correct, then the block is added to the blockchain. Like here, block one or block next block. But if the case is that if the transaction, if it contains any type of false transaction, the validator faces slashing as a penalty. What is slashing? As I mentioned that validators take their own money and validators are responsible for adding the blocks to the blockchain. If any block fails down the verification due to the contaminant of transaction, validators lose their own money as well. So this particular thing is known as slashing. When validators lose their own money or the coin they have staked, that is what we call slashing. This is faced by the validators. So after the validator successfully adds the new blockchain to the new block to the blockchain, it becomes a part of the blockchain. After our block has been become the part of the entire blockchain, so the validator receives a reward. As in the previous case, we might have seen that where the miner receives a block reward along with the transaction fees. Here, also the validators receive the same thing, validate block reward as well as the transaction fees. So this was about the proof of stake. It's being currently used by Solana and Ethereum 2.0. So do you guys have any doubt regarding this? Acha, Bhaiya, could you explain the slashing part again? Okay, Suryanshu. So slashing. As I said, validators that are chosen are responsible for adding the block to the blockchain. Before adding the blockchain, the created block is broadcasted among all the other nodes or the validators for the verification. If the verification comes like the outcome is false due to the false transaction or contaminated transactions, the validator faces slashing as a penalty. You can refer it to as a penalty. If your block that you created is rejected, the money you staked or the coins you staked will be reduced. That is what penalty is. So this entire thing is known as slashing. So I hope that's clear, Suryansu. So I guess it's all right. So I guess no one has any other doubt. If you guys are not comfortable in speaking in the meeting, you can drop your doubts in the comment section as well. So, so this was about the two major consensus mechanism that was used currently, like proof of work and proof of stake. So we have also built two websites for block style visual representation of consensus mechanism and detailed visuals on consensus mechanism. Okay, Aswar, we will discuss on that, which is better. So I will also send these site links in the chat as well. Let me open the first site. I'm sending the link in the chat section. So this is the link to the first section, and no worries, the entire session will be recorded and sent in the YouTube, as well as the link to the slides will also be sent there. So blockchain consensus mechanism. The first one is proof of work. This site is like gives you the visual block style representation for the better and easy understanding for any beginner. So miners compete with their computing power, as I said, solve the puzzle or the nonce to find the correct value of hash. The winner or the first one to solve the correct nonce gets add to the block and receives the transaction or fees and as well as the block reward. The network verifies and accepts the block. Here is the detailed explanation. Transactions arrive, users submit transaction to the network for processing. Miners compete for the correct value of nonce as well as the hash among each other. Winner is found and is rewarded with the transaction fees as well as block reward. So as you can see the key features as well as you. Next come to the proof of stake. Validators stake their own crypto money. Random selection take place. Network selects validator and weighted by the stake. More you stake, more the amount you stake, there is a higher chance of getting selected as the lead validator. Proposed block. Other validators after the proposed block is created, other validators validate the block and consensus other validators verify. If the verification is successful, the block is added to the blockchain. So here are the key features: low energy consumption, faster transaction, environment friendly, and security through economic stake. So here is an something beyond proof of work and proof of stake. Comes the proof of history that was introduced in Solana. In Solana, proof of stake is not the only consensus mechanism it works. It works along with proof of history, a new type of consensus mechanism. It's not exactly a consensus mechanism, but a helping hand that improves the speed as well as transaction per second of Solana. We will discuss it in like later on. So this is the block style representation of that. Key features. There are some multiple consensus mechanisms other than these three, as well as delegated proof of stake, proof of authority, proof of capacity, and many others. So now let's compare proof of work and proof of stake. As someone asked, security method, computational power, and economic stake. In proof of work, as I said, miner. You guys have must have about the news that crypto miners are buying multiple of GPUs and GPU rigs. What's the reason behind that? It's because they want to increase their computational power so that they stand ahead of someone else. So this is why the security method here comes the computational power. And in proof of stake, as the selection for the lead validator heavily depends upon the amount you have staked, so economic stake is as the security method. Energy consumption. In the proof of stake, as you are using high computational power, so it requires heavy machinery like hardware for the computation process. Very high energy is consumed, and in proof of stake, it's very low. Transaction speed. The proof of work is a bit slow, 7 transactions per second with the speed of Bitcoin actually. And in proof of stake, it's 1,000 transactions per second, more than 1,000. And with the introduction of proof of history, the Solana has achieved more than 69,000 transactions per second. So we will explain and go understand how proof of history works. Entry barrier, expensive hardware, and own cryptocurrency. Examples: Bitcoin is the very prime example of proof of work, and for proof of stake, Ethereum 2.0. And validator selection. The first one to solve the puzzle in the proof of work is the true validator, and in here, randomly selected but weighted by the stake. So this is the first site for the block visual style representation of the various consensus mechanism. Let's go to the second site we have made. So this is a site where all you will find the various proof like type of consensus mechanism. in a better format. Like this site basically gives you the short notes on the features and the pros and cons of the type of consensus mechanism, as well as the sorting feature is here. Let me share this link with you guys. So I have sent the site link for the second website here as well. So as you can see here, proof of work, proof of stake, delegated proof of stake, proof of history, and proof of authority mechanisms compare as well. In the compare section, you can compare all the things. You can, for example, proof of work and proof of stake. The transaction per second is 7 year, 10,000 year. Energy efficiency, proof of work is less energy efficient as compared to proof of stake. Security, decentralization, category, and examples. So as I mentioned earlier, proof of history in collaboration with the proof of stake had Solana to achieve a higher speed of more than 65,000 transactions per second. Now it's something around 75,000. There are some other consensus mechanism as well, proof of authority, proof of history, delegated proof of stake. In the analysis tab, you can see about the performance matrices, for example, security and the decentralization comparison. So for the proof of work, security is one of the highest because you need high computational power. That means high and more powerful hardware for computation and standing ahead of thousands of miners currently existing. Decentralization as well. Here comes the proof of stake, delegated proof of stake, proof of history, and proof of authority. So next comes to the overall conclusion, energy analytics as well. Here comes the energy consumptions and ratio to the efficiency. So proof of work, the highest energy consumption is there, and energy efficient ratio is not very good. But proof of stake, as energy consumption is very less because you don't require a very large amount and high powered GPUs for that, and the efficiency is almost higher. Same goes with the delegated proof of stake, proof of history, and proof of authority. So, as I have explained about the proof of work and proof of stake, I would suggest you guys to look up into the internet and explore more about the proof of history, delegated proof of stake, and other consensus mechanism, as well as an in-depth research about the proof of work and proof of stake. Actually, there are multiple things going under the hood behind this simple explanation. So, let's see various type of consensus mechanism. Computational comes the proof of work. Stake based comes the proof of stake. Delegated is the delegated proof of stake. Temporal means proof of history. Authority based means proof of authority. So these are the major kinds of consistent mechanisms out there. There are much more also. So let's go back to the session. So this was all about the consensus mechanism as well. Proof of stake, proof of history, two sites for the visual representation and better understanding of the site. Do you guys have any doubts regarding this? If you guys have any doubts, you can drop in the comment section as well. I guess no one has any doubts. So the session is being recorded and it will be uploaded in the YouTube very soon. You can join our community where all the details of the past session as well as the upcoming sessions will be shared along with the resources that was being followed. So let me show you on blockchain demo, the hashing. As I mentioned earlier, hashing is the process of converting an input given to the hash function to a fixed length string. So Bitcoin uses SAT256 hashing algorithm. That means that any input you give, it will give an output of 256 bit of string. Let me share this site with you guys. You can try it on your own. So as of now, the data is empty. You can see the hash is by default hash. Let me put some data here. Consensus mechanism. As you can see, for this consensus mechanism data, this is the hash we got from 0DA, 4A, 1A, something else. If I do any little bit of change, for example, adding a space, you can see the hash is changed. So this is the hashing process actually. So you can like refer it as that hashing function is like a box. If you give any input to the box, it will give you an output of 256 bit of string, different for different inputs. Any slight change in the input can change the hash abruptly. Like here is the block. Let's suppose it's a block one. It's a very wonderful site you can visit. And this Brownwood, it's the site has been used by many blockchain educators for demonstrating the use and the working of blockchain as well. Using this site, you can actually understand how is this working. Now let's see the block number one. Nonce, the default nonce is some 72608 and the hash. And if I input some data, open code, NIT, Raulkela, consensus mechanism. As you can see, the block has turned red because the hash doesn't match with the like the new data because the hash is here like as I said before, is the final output of hashing together the nonce, the data, and the block as well as the block header itself. If I mine it, it will take some time. As you can see, for the new data, the previous nonce value changed and we got a new hash. Let me do it once more. Just see the hash value 135824. Let me change this as well 123 session 2 mine. As you can see, we got a new nonce value, new hash value just because we changed the block number or the block ID and the data the block content. So this is the thing about an individual block. Now comes to the blockchain part. So, as I said, blockchain refers to the chain of individual blocks and each block a reference string to the previous block. As you can see, this is the block one. Previous block is 00 as it is the starting block, also known as the genesis block. Hash is some random. Let's choose a random block in between. Block number three. If I change or add any new data here, let it be ABC. As you can see, it turned red because I have changed the existing block number three data due to which there's a change in the current hash and the current hash is not matching with the previous hash. It used to match. The entire chain is broke. If I will mine it, I have to mine these blocks individually for correcting their previous hash value and the current hash value as well. So here is the new blockchain. So this is all about how the hashing actually works and how it helps connecting the block to its previous block. And this is about proof of stake, proof of history, visual representation, the site for understanding and going through the different consensus mechanism, the block style visual representation as well. So as I said, proof of history. Let's search about proof of history a bit. As you can see, proof of history is a consensus mechanism used by Solana that acts as a cryptographic clock for a network. Proof of history. This is a wonderful explanation about proof of history. Let me share with the link. Go through this article, like you will get a better understanding of proof of history. Let me explain you what proof of history actually does. So, as you can see in the previous like consensus mechanism, proof of stake as well as proof of work, the validators or the miners choose from the pool of transactions, where depending upon the transaction fee they paid and transaction age, transaction size as well. But in proof of history, the concept is a bit new. They, like as you can see, they are using a concept of timestamps and verifiable delay functions video. So let me explain you, bro, what is that means. So when a transaction enters a blockchain network, the transaction is like given a timestamp. So let me explain you. Let it be a pool of transaction, like a memory pool itself, containing various transactions in it. Like let it be transaction one. Here comes the transaction two. Here comes the transaction three. Here comes the transaction four, transaction five, transaction six. So in the default system, we knew that miners slash validators were able to choose the transaction from this memory pool and memory pool and put it in the ledger system. This is the ledger. Let us suppose blockchain ledger. So miners and the validators had the power to choose the transaction depending upon the transaction fee they paid, transaction age, and transaction size to put it into the bundle into the block and put it into the blockchain. But now, in proof of history, what is the new technique is that every event streamline has been streamlined so that first, for example, transaction one is the first event that came to the blockchain network, then came the transaction two, transaction three, transaction four, five, and less than six. Every transaction is given a cryptographic timestamp. It's that cryptographic timestamp doesn't mean the actual time in the world that is been hashed or something. It's a like cryptographic timestamp has been given with the help of verifiable delayed function. So let me explain that. When a series of events enters to the blockchain, every event is been given a particular cryptographic timestamp. As of now, it you can like refer it to as a normal timestamp, and that timestamp is been hashed to into a hash, like using a hash function to a particular hash, and that hash is used in the second event to and using the data of the second event as well as the hash of the first event, the new hash has been found. So basically what it does is it forms a chain of events, and each, let it be one, let it be two, let it be three, let it be four, let it be five, and each event is been linked with the previous event. So what's the benefit of actually doing this? This is the same as the proof of work or proof of stake as well. So the benefit is that the validators or the validators, if I use the term correctly, doesn't require to mine or validate each block individually. They have to just rerun the hash function and check that every hash is linked to each other. So this is how like proof of history in like working with the proof of stake helps Solana to achieve such a higher speed. So I would recommend you guys to visit the proof of history blog I have sent in the description. It will give a detailed explanation how actually proof of history works and why it was needed. So that was about proof of history in a brief overview. Do you guys have any other doubts or any doubts regarding resources where you can start, where you can know about these things? So let me guys share you an article. So this is an article about the introduction to the blockchain, where all the details about the blockchain and the working of blockchain has been explained in a very simple manner that will be helpful to learn about or get started with the blockchain itself. I'm sending this link in the chat section as well. And also the session link, the first session link that was taken in the chat section as well. As someone asked, yes, where to start and how to do some cryptocurrency combined with other features, tokenization, and AI coins. Okay, let me start with the first question, like where to start cryptocurrencies and how to start. If we go into the developmental stuff, ciphering updraft is one of the best education platform free of all cost. Every course here is free for blockchain. Explore all courses. There are multiple courses starting from blockchain basics to smart contract development, advanced foundry, introduction to Python and Viper. Every course is fair and beginner and advanced friendly. You can progress as you go along. Multiple divisions as well. Full stack development in Web3. This is a very good educational platform for Web3 developers who are getting started on. Meta School. Meta School helps you learn AI and Web3. That like helps you teaching and understanding how you can incorporate AI into the Web3 development. You can also get multiple courses here, like on multiple different chains. There is another site, Ryzen, where as you can see together we rise in Web3. It's a platform that provides various boot camps to learn Web3 development. As you can see, Stacks Full Stack Development Bootcamp in India. Multiple things are going on here. And multiple. They also sponsor hackathons and provide predefined courses that help you to transition into Web3. Let me share the links as well. And on the later part, how can combine with other fields such as tokenization, RWA, AI cons. I would suggest that you can once you get started with developmental field or cryptocurrencies, exploring on your own, you will figure it out at all. YouTube is an excellent resource as well as AI nowadays will give an excellent platform to learn these things. I have said all the four things in here. So you guys can join our community to stay updated with our upcoming session as well as events. So that was for today's session. The session is officially over. If you guys have any doubt, you can ask and stay. And if not, you can leave. Thank you for attending the today's session. So I am ending the session now.